Alright, we're going to try this again since YouTube was being difficult with me the last time. So, we're talking about Trig section 2.4 exponential functions. And we know that exponential functions look like this: y equals ab to the x power. Notice that the variable, the independent variable, is an exponent. Okay? That's what separates it from a fixed power exponent like a parabola, x squared, or a cubic function, x to the third power. And this is just another form of it. F of x equals ab to the x power. B, we've always identified in Algebra 2 as the growth factor, whereas A can either be thought of as the starting amount if you're talking about a story problem, or the y-intercept. Remember, when x is 0, anything to the 0 power would be 1, and then you'd just be left with A. Therefore, 0 for x and A for y, that would be the y-intercept, more commonly known. We have two different types of exponential functions. We've got the when the growth factor is greater than 1, we call it exponential growth. And when it's between 0 and 1, we call it exponential decay. Notice that we will not have any kind of negative growth factor. The different types of graphs, exponential growth starts low on the left, and as we move from left to right, it gets bigger and bigger and bigger. We say that it is strictly increasing. In fact, we use that term because we're going from left to right, and the y values keep getting bigger. And not only is it strictly increasing, but it also is increasing without bound. It never stops. There's no asymptote, horizontal asymptote on the high side, which stops it from continuing. It does have a domain of all real numbers because it keeps getting wider and wider in both the x direction on the left, the negatives, and on the right, the positives. The range does go from 0 on up. Notice that it is not equal to. That's because of that asymptote, right? We've talked about how y equals 0, commonly referred to as the x-axis. That's the y equals 0 is his official name, like on tax forms, but on the street we call it x-axis. And then I also want to point out to you that the domain and range are the same for exponential decay. All reals for the domain and greater than 0 for the y's. I have also noted to you on both graphs that the y-intercept, A, is labeled right there. And this one decreases. It's called strictly decreasing because as you move from left to right in the graph, the y values are getting smaller. Always, always, always. Even though they're not dropping a lot over this way, they are still dropping as you continue to the right farther and farther. But we also can understand that it's decreasing with a bound because of that horizontal asymptote, which is the boundary below. Let's give you an example. In example 1, we have a population of 3,424,000. That is the starting population, and that was measured in New Zealand in the year 1993. This is according to example 1 that's in our textbook. The growth rate, not to be confused with the growth factor, but the growth rate is increasing at 1.3%. Increasing at 1.3%. Now, we talked about how to change the growth rate into a growth factor. The growth factor is equal to 1 plus the growth rate. So, for instance, in this example, we have a positive 0.013. Why is it positive? Because of the word increasing. Increasing at 1.3%. So we have 1 plus 0.013. That's where we get 1.013. Hard to see that 1 right there, but there it is. And when we write our equation, it looks like this. We have to have the starting amount. That's the A value. You'll notice that I converted mine into millions instead of having to write all those zeros. I know there's only 3 of them, but you know what I'm talking about. the growth factor, now you know what a lot of kids do. A lot of kids will just write 0.013 for their growth factor. Okay, now, what does that mean? Well, of course that means exponential decay. That would happen to be a 98.7% loss. That means every year we'd be losing 98.7% of the people from the year before. It will not take long before we're all dead. Not a good idea. So, don't be the kid that forgets that, right? You have to add it to 1. Now, if this had said it was decreasing by 1.3%, then that sign right there would have been a minus, right? Because it would have been a negative growth rate, because it would have been going down. And when I took 1 plus the negative amount of this, then that would have pushed me down to 0.987, which happens to be a number smaller than 1, which would cause it to be exponential decay. Now, you'll notice that I wrote over here, X happens to be years after 1993. So what would you put in for 1994? Of course you'd put a 1 in there. 1995, 2. 2013, you put in a 20. Okay? I do want you to solve this equation right here. Solve for the year. So in your notes right now, here's your equation. And I want you to solve that equation for X. And then we'll talk about it in class. See ya.